have been Cosx. Then, and here you need to center it at x0. First off, either you can write the formula, what you require, all those ingredients to solve it. F dash x, F
Cos
double dash
x.
x.
But
Derivative of
f
cos
dash
x
x.
is,
Minus sign.
and then derivative of sine is cos. So minus sign will remain
Yeah.
there. And then cos is minus sign, so minus minus plus sign. And this chain goes like this. Let's only find up till this much. Then
X equals sin x. Yeah.
so this is fx. Now what happens usually? Our
Ma'am,
fx
so
is
again, I'm sorry.
uh-huh.
This was I figured I skipped a step. So we are nothing but we're again doing a UV rule here only, right?
um no qv minus is here only. I did not touch minus. So sine
No,
is
so we are
cos.
sin x. Oh, x is a variable. Oh, right. X is not a constant.
Scalar multiplication.
It's scalar multiplication. Got it. X is not a constant. It's a variable here.
Yeah,
It's an independent variable. So it's not a UV rule. So it's got it. So
it's
got it. Got it.
independent. Okay. Now, if you elaborate this by Taylor expansion, what will be the equation, like the expression?
So the Taylor expansion would be fx equals
So it
f.
is A. That is cos A. FA.
Yeah, fa. Okay, yes. Cos a plus uh f dash a would be
I mean, you can remember
minus
it
sin
this
a.
way. You can remember it this way. You write it here and then you take the derivative of it, right? And you write x minus a 1 factorial, correct? Then you will
Uh,
take the derivative of this and so on.
Double derivative of that x minus a.
So for cos it is,
So it would be minus sin a into
and
x minus a.
basically base is x0. So what will happen? X means the a is 0 initial because I need to leave the answer in x form only. I'll just
Hmm.
simply put the value. Cos 0 is 1, sin 0 is 0. So what is the next value?
Yes. So cos 0 is 1. Uh, s- Ma'am, but yeah, wait, cos x. Oh, got it. Cos 0 is 1. No, no, 1 second. I have to refer to the table. Yeah, cos 0 is 1.
Sin 0 is 0.
And minus sine 0 uh, is 0, yes. And then next it would be, then next we have again sine 0 is 0. So the form would be
Hmm.
1 plus
Uh, okay.
no cos 0. No, no, 1.
Okay,
Oh
what are
yeah,
we
yeah.
going to do here?
Yeah.
Uh,
One
huh?
plus 0 तो नहीं हुआ. So x minus 0. 1 plus x.
Why,
No,
if
no,
it
no.
is
1 plus
zero,
0, 0,
zero means
0.
hmm,
Yeah. 0 plus nexus. F double dash is sin x. So sin x is again 0.
so basically what we are
No, f
doing,
double dash is minus cos x. So that would be minus 1 into minus cos 0 minus cos x minus a x minus would be
right?
1 into x square
Huh?
divided by 2 into 1. So divide by 2.
Correct?
Then you've got again sin x. So 0 into that. So it's 0. Yeah, so
Right.
this is the form.
Yeah, so every single time for Cosx expansion by Taylor series, it is 1 minus even power plus even power minus even power. This goes like this, okay?
Got it, ma'am.
2 factorial, then it has to be divided from this also. Do you want to, do you want me to elaborate it further or you got it?
I got it, ma'am. But then we don't need to, right?
No, no, no.
Oh
It's
yeah,
just first three elements, fine.
first three elements. Yeah. But then, ma'am, in this case, unlike the last polynomial algebraic expression that you gave, and the question, in the question that you gave, the
Huh?
equation 2x, the function that you gave 2x minus 2x square, over there we came to know that n equals 3 because we came to know that after the third differentiation, there's no point for us to do the differentiation. So we
Correct,
took the first three terms. Over
correct,
here, we don't really know, right? Because it keeps alternating cos
correct.
x sin x, then it becomes minus. Now next step it becomes cos x again.
Yeah. So it is alternating function, and here you can have this series. You know, when you are given 2, 4, 6 and ask, okay, what will be the
Yeah,
next? So you know. So you can relate with the pattern and get the next term. Okay. So first three
got it.
elements are fine, and then it's you can simply write epsilon, and then it's done.
Got
So
it, ma'am. I'll solve
this
this.
was one trigonometric function. Initially, we started with algebraic function, and this is another. Now you need to find out the Taylor expansion for x is equals to 3. Is it doable?
I can, yeah.
Okay. Now when you got it, if you remember you asked me in the last class that, ma'am, if I have to find out the geometrical significance of convexivity and concavity, how will we do that?
Yeah, yeah.
Tell me what are convex function?
Ma'am, convex functions are functions that are convex are increasing at the critical point, and concave are decreasing from the critical point.
Right. Do you remember the ray diagram from your lower classes, convex and concave lens, mirror?
Yeah,
So, inspired with the fact that how the curve looks like, curvature looks like, we have given the name to these functions. So, curves,
right.
if curve is upwards, that means if your curve is there and you take any point and make a tangent. Do you know what is tangent?
Yeah.
What is the difference between tangent chord and secant?
Tangent and secant I know. Chord I'm not very sure, ma'am.
So let's
So
say
if you draw a curve, I'll be able to tell you. If it's a circle, so tangent, yeah.
you have annotation, you can draw it if you want.
Okay. Yes, I'll draw it. This is tangent.
Right.
This is a chord.
And the
If
third
I'm
one?
not wrong, that's and the secant. Oh, secant. Is this secant? Oh, that would be a chord as well. Does a secant
Yeah, you are doing right. So maybe I made you confused. So see, the point is tangent touches a curve at one point. Chord again touches it from inside. I mean, it is a line segment which intersects. But secant is the line. If you extend the chord and make it a line, then that becomes a secant. Okay.
okay, got it.
Now I'm
Right.
telling
So that's why if I can annotate a bit more. So when I was learning differentiation,
you.
and if this is a curve, and if I draw a point of tangency here, sorry, yeah, this is a point of tangent here,
Hmm,
and this is one more point. So over here, if let's say the point is x,
right.
and here the point is x plus h,
Hmm,
and when and this is a secant. Oh, sorry. If I'm not wrong, this becomes a secant from the point of tangency. And when you move when h tends to 0,
hmm.
sorry. Your point of secant then moves to your point of tangency. And
Correct.
that's how you find curve, if I'm not wrong.
Yeah, nice interpretation. That's correct. So see, what I'm trying to say here, this is not the annotation point. I'm using the pen from the note itself. Just bear with- huh. Okay, so what happens? Convex curve means the curve upwards. And upwards
Yeah.
means I need to have something downwards with reference to which I can say that it is upwards. So the tangent always lie below the curve. If this is the curve, it's tangent. I mean, this is neither convex nor concave. But let's say if it is the curve,
The
tangent,
tangency point always lies below the. That's
right,
for your convex.
tangent always below. And that means chord always above or on the graph.
That's
So,
convex.
so see, if
So,
I have chord, I need to make it using 2 points of graph. Let's say AB.
you know,
So that means chord has to be either on on the above on the graph or above the graph, right?
Got it, ma'am. Just one second, I note that down.
Sure.
Function or below. Got it, ma'am.
Now, if I ask you fx is equal to x squared,
Hmm.
I'm sharing my screen so as to tell you the Desmos thing. Tell me firstly, is it convex or concave? Fx is equal to x squared.
It's a convex plane. It's an upward sloping curve. It has a parabola. No, it does not.
It is a parabola.
Yeah, it is a parabola.
See,
Yes.
my screen is visible, right?
Yeah.
So I'm writing here x squared. Okay.
Yeah.
You can see this is upward. Now I want to make a tangent. Do you know how do we find out the equation? Sorry about that. Equation of any line.
Equation of what, ma'am?
Equation of any line. So let's say if I have to find out equation touching this point or this point, then the formula is y minus y1 is equals to m into x minus x1, right?
Mx minus x1. Yes.
Where m is slope and we know slope is change in y over change in x. That's
Changing
how
y
this
by changing
formula
x.
comes. Yeah.
Yeah.
But if I want to, if I want to know about the line, whether it is touching it or making a chord or making a tangent out of, for this graph, then I can have the regression. We can do
Got it.
regression using Desmos. What is regression?
Ma'am, regression is nothing but to know the change in y with 1 unit of change in x.
Correct. The
How much
change.
of y is being caused by a change in x? How much of a
Correct.
change in y is being caused by a change in x?
So in Desmos,
It's an error term.
the sign for regression is this. And we use this slope intercept form to create a table and see what I'm doing.
Okay.
Uh, Here, okay, I need to stop the annotation now. Okay, here is the plus sign. You select and create a table. Okay,
Okay.
now you choose any of the points which you think that can lie in on the periphery or something. We can of course change them later on. So let's say I have x1 0.7 and y1 1.7. This is 1 point,
Hmm.
or maybe zero point 0.7 and 0. This is also okay. 0 and 1. And if I
Got
want
it,
to
ma'am.
make a line, so what I'll do, y regression sign m. Now see, my pointers are what? X1, Y1, right? Here.
Yeah.
So I have to write here x1. So this is my slope intercept form. So I'm writing here y mx1 plus
Let's
c.
see. C is your intercept.
Something is wrong. Yeah, y1. I did not write y1.
The one. Hmm.
So you can see it has given me
R square value is 0.01.
everything. What
It's
is
a
the
correlation
intercept?
as well as regression.
Yeah. What is the intercept? They are negatively correlated. So can you see if it is the chord, because it is a convex curve, So it is moving upwards. If you are unable
Yeah.
to, though we know and we have learned about parabola, so we know that x square will form this way and it will be, upwards only. But for some of the graphs, until we make a table or we plot it, we are unable to find out where it is heading to, right?
Okay.
So for those, you can use regression and see the code and the tangent. You choose any point. You will see if I'm choosing this and make a line, it will go here.
Right.
So the tangent will always be below the graph, right? If it is a tangent, it will be below the graph, not above, right? Or no?
Chord will be either below or above.
Code, code either on the graph
Okay.
or above. Is it fine?
Or above. Got it.
Now
Not below.
let's,
Yes, it can be below.
huh, you need to try it. I mean, using Desmos, you need to do it.
Okay, ma'am.
And now, if I do for concave, can you suggest me any concave function?
Mm.
So basically, if concave is
Ma'am,
what? Uh,
and it could be a negative function.
correct. If negative is giving me positive, it is convex. If positive is giving me negative, I mean, if I'm getting positive, negative, and I'm getting negatives, then it is concave. Can I do minus x square? Or I need to stop
Minus x
annotation.
square. Mm. Oh, I'm not annotating anything.
No, no, I need to. I was supposed to stop the annotation, otherwise it was not letting me
Oh,
click
okay.
on anything. Where
Okay.
is annotation? Can you see minus x square?
Yeah. And yeah, and the regression points, the chord is below,
Yeah. Chord is below and tangent is up,
up. Yeah.
above the graph. Is it fine?
Hmm.
Let's talk about log x. What do you think? Log x is what?
Below. Log of x. Yeah.
Decreasing. Concave, right? I'm removing these, then you'll be able to see. So this is of green color line. So basically, if you derivate,
Ma'am,
this,
is it decreasing?
you know why? This is 1 by x.
1 upon x.
So it is linear function. It will give you negative values, right? Why it is negative? If we use that concept, the tangent is up, the code is code is below.
On or above. Oh, sorry, below.
This is a concave function. And if you want to go with the derivative test wala thing, then also log x is giving you 1 by x. And then if you do double derivative, it will give you minus 1 by x square. What do you think? Is it positive?
No, it's a negative. It's a
Is it
downward
here?
sloping. Yeah. So again, in my mind, it's just like I'm looking at the curve, and
Hmm.
as the x is going, as x is increasing, your y is also increasing. So that in my mind that was it. But then we're not looking at that. We're looking at the second derivative
No,
condition.
but where y is increasing? See?
Ma'am, as x is increasing, y is increasing. No.
Hold on. Can you see what's the value of y?
Yeah.
But considering these points, y is almost here stable and here it is going down. Minus
Yeah, ma'am.
10,
But then
minus
as
20.
x is increasing, it is becoming more stable, no?
See, it's not going anywhere. It's tending to zero. 0 point something. Are you getting my point? Y is tending to zero.
Yeah.
This is one of the questions given in your question papers, in which can you see the screen?
Yes, ma'am, I can.
Okay. So question is approximate e raised by x at x equals 0 with a Taylor polynomial of order 3 and 4, and then compute the values of these approximation. So how will you approach it?
Acha.
Hmm.
Your differentiation of EX is EX only, right?
Yes. Hmm.
At x equals 0.
Yeah. So your fx is e raised by x. Now tell me what are you going to do?
F dash x is e raised to x. Ma'am, but however, how do you know how much would you expand here? Because first
This,
order differentiation, second order differentiation. Oh,
yeah. So when it is the polynomial of three order, expand it up to three derivatives. So one is constant, then you have the series of f dash, what you will write here. So initially you will put fa, then f dash a,
F dash a, yeah, f a plus f dash a, x minus a, plus
x minus a, x
plus
minus
f
a whole
double dash
square.
x minus a the whole square divided
Yes,
by
yes.
2 2 2, yeah,
Factorial.
sorry, yeah, factorial. F triple dash a, or third derivative of your fx a, x minus a the whole cube divided by 3 factorial.
So these are
This is
three
conjugation.
derivatives. So three order. So you'll elaborate
Hmm.
it, and then you'll find the polynomial for, I mean, the fourth order. Then everything will be same, and then you will expand it for the fourth value also.
F fourth order x minus a the raised to 4 divided by 4, yeah.
Okay.
Ma'am, but then I have a question. What is x minus a the whole? Oh, here I have to.
So you can
I was
see
asking
that
what's x minus a
initial,
the whole raised to 4.
yeah,
उसका ये क्या रहेगा when you open the brackets?
yeah.
Or
So
should I go
initial,
through the expansion formula that you gave me the other day?
yeah. So initial, yeah. Initially, you have x here only and no other values. So you can simply consider it as f dash ax, or you can consider x minus a as h, the difference,
Okay.
or
I think,
b,
but the
or
B form
whatever.
that you had given me the other day.
Yes, yes. So when you will do fa for 0, a is 0, right?
Yeah.
So you have this h as So you will expand it for e raised to power h, which will be what? Initially, you will put a as 0. So e raised to
0.
power 0 is 1. Then tell me the differentiation of e raised to power x.
Ma'am, over here,
Yeah.
yeah, e raised to power 0, that's, oh, e raised to power, a is 0 here, right?
Yes.
So 1
And then if it is
into
h, then you will put
x.
h. If you are assuming it as x only, then you will put x only. So if it is e raised to power x, so you'll write x, right? Plus,
Yeah,
then double derivative. So here you had e raised to power x. When you will do double derivative, it is again e raised to power x.
e raised to power x. Again, it's e raised to e is 0, that's again
Yeah,
1.
1. Then this will be x squared by 2. A is 0.
Ma'am, but I have a doubt here, ma'am.
Yes, yes.
So
Go
it's
on.
it's a fundamental doubt. Why are we assuming A here? Why are we assuming, when do we assume X here and when do we assume H here?
Okay. So basically, I need to expand e raised to power x. I'll think about it like after elaborating, you can keep a throughout and later on you can start putting in the values. When you are asked that it is at one point, then that point, the distance between x and that point you are finding out, like the distance, the difference. And when it is asked that find out again, find out that expansion you've got after e raised to power x. Now find out
Hmm.
for h is equal to 0.2, h is equal to 1. So again, these are the values of x only, which you have to put in. This
Got
is
it,
the
ma'am. This
difference.
this this is okay. This is nothing but we derive this from
Same
the
formula.
basics of differentiation, right? Why we do
Yes,
differentiation is to when we move along the curve from x to x plus h.
correct, correct.
So,
Limits.
okay, got it.
So
Got it.
what will be the, this is first order, second order. What will be the third order?
So again, it's going to be 1x into,
Huh.
oh sorry, not going to be 1x. It's going to be x cube divided by 3 into 2, 6.
Okay, so this is the answer, that is 1 plus x square by 2 plus x cubed by 6. This is this part.
Yeah, third order expansion.
Yeah. Now, fourth. So I'll write all those previous values and then this one. What it will be? The fourth order.
It's again going to be x raised to 4 divided by 4 into 3 to 2, 24.
So this is up till this much I've got. Because it was approximation, so that's why I did not apply equal to sign here.
Right.
Now I need to compute it for h is equal to 0.2 because they are asking for h. So that's why, I mean, you can change it into e raised to power h. Okay. Is this fine?
Got it, ma'am. And then are we expected to substitute the value?
Correct. Now, when you will substitute using the calculator and everything, so you will get e raised to power 0.2 from here, then e raised to power 0.2 from fourth order, then e raised to power 1 from here, and then e raised to power 1 from this.
Fourth
And
order.
then
Okay.
you have to also, this is the approximation. Then you have to compare it with actual value also. So you need
How,
to
ma'am?
calculate e raised to power 0.2. I mean, just type in the calculator and get the exact value. You need to compute, I mean, compare whether, I mean, how much closer or precise the value is using the expansion. Is this fine?
Yes, ma'am. Understood, ma'am.
Great. So this was one of the questions, and just like we did it for positive definite, every particular question has this sort of thing to elaborate it for Taylor expansion. I'm hoping that you'll be able to do it now. Yeah.
Yes, ma'am. I'll go through it. And also,
Okay.
I have like two, three papers left, problem sets left for finding the range now, the positive or negative definite. I'll do that, and simultaneously I'll do this and I'll tell you, ma'am.
Okay. So you're having dinner now?
Yeah, I just finished. I just logged out. I'm sorry, ma'am, if that's disturbing. That's why I did not.
No,
I'm
it's
taking
not
notes
disturbing.
also.
I'm just concerning about, please be careful while eating that, should not be chaotic.
No, no.
अब अब मैं तुम्हें एक बहुत इंपॉर्टेंट टॉपिक करा रही हूँ अभी तक
Okay, ma'am.
हमने पढ़ा पॉजिटिव डेफिनेट सेमी डेफिनेट इनडेफिनेट नेगेटिव डेफिनेट जो भी हमने पढ़ा all those concepts
Ah,
were related with the matrix. Now we are again moving towards these topics, but this will be an amalgamation of Taylor expansion also. So I am introducing another matrix which is Hessian matrix.
okay, ma'am.
So this question is from your practice test. We'll come to it after getting the concept right. Okay.
Ma'am, it is Hessian, right?
Yeah.
Okay.
Uh, so basically, this Hessian matrix is again a square matrix and a symmetric matrix, just like
Hmm.
we were having it in the quadratic form.
I got that from.
The only difference is it has second order derivatives of a
Oh,
function, and that function has to be in two variables. So it is two-dimensional. So
and the function.
we are right now focusing on 2 by 2 order specifically. So again, we are going to talk about that based on this Hessian matrix. What can be the condition for positive definite and all those things? Okay. So what
Okay,
is
ma'am.
required? This Hessian matrix for a function f is basically partial derivative, double order derivative of f with respect to x. Principal diagonal will again be having x and y, okay?
Hmm.
And then that another diagonal will be having the combination of both x and y.
Got it.
Now, because it is a symmetric matrix, so it has to be equal to its transpose, right?
Yeah.
That's why you will find out that if you calculate this, what does it mean? What
So
is
it's
the
your
order?
cross partial derivative,
Okay, so function
second
has
order.
to be, function has to be, I mean, derivative has to be taken with respect to y or x first.
First is x and then y.
No. So we do it
Oh,
this way. This is first single f, and then whatever. So this is this way, and then d by dx of. Okay,
Oh, got it, ma'am.
and then when it will be other way around, that means we'll do partial derivative with respect to x, and then y comes. Okay,
Got it, ma'am.
but because it is a symmetric matrix, then you will find. Therefore, you will find that these are equal only for this particular case. Okay, though in
What is
derivative,
equal? Your cross partial derivatives are equal, irrespective of
the
which one
order.
you do first.
Yeah.
Okay.
So it doesn't matter whether you will do it for firstly for y and then x, or firstly, though order matters for other questions. But here you will find that whether I'm doing firstly with respect to y and then x, and vice versa, both are giving me same answers. Okay.
Okay.
Let's see. So once this is the model which I'm telling you, once you get this Hessian matrix in place, then you can create a quadratic form out of it, or you can make Hessian matrix from the quadratic equation. For instance, let's say I have this function 1 plus 2x plus 3y plus 4x squared plus 5xy plus 6y squared.
Hmm.
Now let's find out a11, that is double derivative of f with respect to x. And this is partial derivative. That means
Okay,
I
ma'am.
need to keep every other thing constant. Okay.
Constant. Yes. Ma'am, I'll call out the answer.
Yes. Yes. Please tell
It's
me.
2
Mhm.
plus 8x plus 5y.
And then I need my first element is double derivative. I need this. So you will do again with respect to x. What it will be?
Yeah. So it's going to be 8 minus 8, just 8.
8. Then let's find out this one also, leading coefficient.
Hmm. So it's going to be 3 plus 5x plus 12y. And this is going to be 12.
Now comes, so firstly I have this, and then I'll do it with respect to
Which
x.
x, which is 5,
And if you do other way around,
and that is 12. No.
so,
Yeah, x is sorry, that's gonna be 8. No, no. Why? No, 5. 5.
so you can see that it is equal, right?
Yeah, yeah.
Now, once you get this matrix, which is what now? Double derivative of f with respect to x.
So 8,
Hmm,
5, 5, 12.
perfect. Once you get this, this is how you can get matrix. And uh, I'm asked to find out whether it is having maxima or minima,
Hmm.
or is it the condition of definite or indefinite or semi-definite. These sort of questions are asked based on the function given, or Hessian word keyword is used. So what you do, firstly you find out there are various methods. One is you can simply get, this is your D2F, okay? Second order
Yeah.
derivative matrix. You will find out you will find its determinant.
Okay,
What's the
ma'am, I'm
determinant?
looking this down.
What is its determinant?
Ma'am, it's 8 into 12. That is equivalent to 96 minus 25. 71.
Okay. So which is positive? Now,
Hmm.
see, what does it mean? What's the significance of having a positive number or negative number? Basically, the determinant, because it is a 2 by 2 order matrix, determinant is
Yeah.
the product of eigenvalues, generally. Okay?
Okay.
If I don't want to go through that long process, which is complex here, of course, that make a characteristic polynomial, then find out, solve everything and then get the eigenvalues. You can simply assume, because I'm not asked to find out eigenvalues. My main purpose is to get through that definiteness. So what
Yeah.
I'll do, I'll find out the determinant. This determinant is actually the product of eigenvalues. What do you think? If a particular product of two
Ma'am, I have a
values,
question.
yeah,
Is determinant in this case product of eigenvalues because the matrix is symmetrical and 2 by 2 square
yes,
matrix?
yes. For square matrix, generally, it is the product of eigenvalues. I'll show you. Uh, you can, in fact, prove it on your own. Find the eigenvalues using the characteristic polynomial. I mean, you can jot it this down from homework. That get the
Okay.
eigenvalues through characteristic polynomial. And once you get those eigenvalues, do the product. Once you multiply them, you will see that, oh, this is equal to the determinant. Okay.
Got it, ma'am.
Now see, if I have two eigenvalues, let me use the general convention for eigenvalues, which is lambda 1 and lambda 2. So this is the multiplication. Now tell me, if it is positive, what can be the case?
If both of them are negative or both of them are positive.
Perfect. So if both of them are negative and both of them are positive, it is giving me the positive value. I'll call it the positive definite. Okay.
Okay.
And if determinant comes out as negative, tell me what can be the case.
Has to be negative.
Indefinite, because one eigenvalue has to be positive, another one has to be negative. Then only I'll be able to get the negative product, right?
Yeah, one of them has to be negative.
So that means it is fluctuating. It is going to and fro. Is this my network issue or yours?
Oh,
Mine looks fine.
yeah, it was my internet, ma'am. Sorry.
No problem. So I'm saying that means one has to be negative. So it's fluctuating between positive and negative values. Hence, we'll call this condition as indefinite. Okay.
Indefinite. Got it.
So this is one way, I mean, another way of telling that whether the particular
Ma'am,
function
one
is, huh,
question.
hmm,
Ma'am, when both of them, both of the eigenvalues here
yeah,
are uh, are
negative.
negative, do we still call it positive definite?
Yeah, because of the determinant. You remember when we used to find out principal minors?
Yeah.
So in principal minus, we are talking about the determinant only. Determinant of symmetric
Yeah,
matrix.
yeah.
First,
First order, second order, and third order determinant.
what do we call that? I mean, how do we find this out? If determinant is positive, then the positive definite. If determinant is negative, it is right.
Yeah,
So we are, I mean, this is not the exact thing to say whether something is positive definite or not, but this is approximation. We are finding it out using the determinant. Okay.
okay.
Okay. So once you do that, you will be able to get the values and call it. If it is positive definite, that means it is what? Increasing function. And tell me, if it is increasing function, what do you have? Minima or maxima?
It is increasing function is we're gonna have one second, ma'am, I'll tell you. We're gonna have a maxima.
Okay, see,
No, ma'am, we can have either, no?
okay, if I have values from 1 to 3 till infinity, it is increasing function.
Yeah,
Tell me, do you know the maximum value for this?
no.
So for increasing function, we can always have the minima, local minima. I mean, we can have the minimum value because that's the lower limit which I know in the interval. And for decreasing, we can have maxima. Okay. Yes or no?
Alright. Ma'am, but
I got you. So you might be thinking that, ma'am, when we find out critical points or saddle points, like for first order derivative, if I'm finding out
yeah.
df by dx, if it is positive, then I say that it is maxima, right?
Yeah.
Like
And it
in
can still be, and the first order can be positive and thus an increasing function. And then if you substitute the critical value, you could have a maxima with that.
perfect, perfect. Yes. So we are not talking about first order derivative here because second order derivative can only give me the polynomial, that vertex, and that vertex, let's say I'm having this polynomial. It is a
Okay.
decreasing function. So I'll have it,
Yeah.
it's maxima, right?
Yeah.
Maximum vertex. And then if it is increasing, I'll be
Oh, they're
having
gonna
the.
have a minimum.
So I'm talking about, because Hessian matrix is about second order, I'm talking about the second derivative test, okay?
Oh, got it. Makes sense. Got it.
Great. Then comes, can I do Taylor expansion also using this bit? Is there anything which you want to jot down? Like, are you skipping? Is it skipped?
No, ma'am, I've taken them down. I'll prefer solve a sum, I'll get a better idea.
Right. So now I told you about the formula for Taylor expansion in two ways. This is the third way. If you have this matrix, like if you have second order partial derivatives, like the Hessian matrix. So there is another formula, and you'll be able to relate with it. Second order partial derivatives. So what you will do, if you are finding out, you are finding the approximate
Ma'am, so
value.
we are, sorry, ma'am.
Yeah.
So we are doing, यहाँ पे we are doing Taylor expansion
Hmm.
for
Hessian matrix.
Matrix.
So in the notes which you have given me, it is only given in half of the page. And then later on, questions are asked in the, various sets. So it is there in the syllabus.
Okay.
Now, we want to expand this function, fxy. So as
Huh.
usual, in Taylor expansion, we initially have what? Constant,
Your
the value.
f, yeah, the value at f, the value of a at for the equation, not the
Right.
equation, sorry, the function.
And then you will have first order derivative first. If it is with respect to x, now you remember that we used to write x minus a, right?
Yes.
Here the value for x, like the point, is x naught. So I'll write x minus x naught. Okay? Right?
Okay.
Then it was for x with respect to x. Now I'm having with respect to y. If it
Got
is
it.
y, so I'll be having y minus y naught. This is the chain of first order. Then comes second order. Now in second order, you have to do half of double derivative of, it's because we have 2 factorial in denominator in the general form, right?
Yeah.
So what I'm doing, see, you remember that it is fa plus f dash a upon 1 factorial into x plus f
Yeah.
double dash a upon 2 factorial x square. So that's what I'm doing. So for
Oh, okay.
first order, I have used differentiation with respect to x and with respect to y. And these are the points, the difference.
Ma'am, I have a question here. What
Huh.
is x0, y0 here? What are we seeing that?
So you remember very recently, I mean, in the beginning of the class, we elaborated it e raised to power x for e raised to power 0.1 or 0.2. So
Yeah.
similarly, we be given some of the values like expand it for 2 comma 1. So those points around which you are asked for the approximate value, those are x naught, y naught values. Okay, is it clear? Okay, let me tell you again.
Mm.
We elaborated e raised to power x.
Yeah.
And the question has asked me what's the value when h is 0.1, what's the value when h is 1.2, whatever. So
Hmm.
similarly, question will be asked in 2 dimension that find the value for this particular function when x is 2, y is 1.
Okay.
You will be given with some of the values. So that value, that around which you have to find out the approximation, that is x naught, y naught. Is it fine?
हाँ
I'll
समझ में
we'll
आया.
take we'll take one example, don't worry. तो अभी हम क्या कर रहे हैं?
समझ.
We are having second order now, second order derivative. And in second derivative, what we have here in the general form, 2 factorial, right? In denominator.
So x0 y0 are ordered pair. Is an ordered
Yes.
pair.
Yes. Coordinates. I mean the values, yes. Ordered pair. Coordinate we can't say. Okay. In the second order, in this form, in the general form, we have 2 factorial in denominator, right? So
Yeah.
that means 2. For second order, I'm having 1 by 2, okay?
Hmm.
So first up, with respect to x, and then you know that the value here is x square. So what it will be here?
Yeah.
X minus x naught
X
whole
minus
square.
x to the whole square. Yeah.
Good. Then again with respect to y,
Oh,
and
समझ गया.
tell me what it will be having.
So 1 upon 2. Oh, that is y minus y0 the whole square.
Correct. And similarly, if you want to find out third order, it will be having 3 factorial, 3 to the 6, 1 by 6. And it will go on and on. Okay. But what we are having here, because it is Hessian matrix, it will be having up till second order only. So we are not having any other further terms. Okay.
Okay.
Now tell me, we are done with. Okay, tell me, am I missing here something from the Hessian matrix? Any element?
Mm,
Let
no,
me show you
ma'am.
Hessian matrix.
Oh yeah,
Uh,
cross derivatives.
so it will be again, so we are not putting half here because it is a single term. So what it will be? D2f by dx dy. So it will be x minus x naught into y minus y naught.
Got it. So
Why
plus,
I'm not putting here half? Because it will be the same for both of them. If I'll put dy dx, so half half it becomes 1, right?
yeah. So since it's the same.
Yes, for symmetric matrix. It's particularly for Hessian, okay? Now, if the same question, I think, do you have this question? Uh,
Yeah,
you
just
found
writing it
out
down.
everything. 1 plus 2x plus 3y plus 4xy plus 5xy 6y. Okay, let's do the expansion for this. Let's say if you are asked that this is your function, again, and then find the value. This was y. Find its value at 0, 0. Okay,
Okay.
now try this on. Put down the values in this expansion.
Okay. So now I have. So let me look at the matrix.
Your
So
Hessian.
f x x equals 8, f y y equals 12, f x y f y x equals 5. So at ma'am, we are going to find at 0 comma 0.
Yes.